What's up guys? Today we're going to be doing some more difficult wave problems that require 2 steps of analytical thinking. So let's see if you guys can do them. If 2 whales are 1500 kilometers apart and emit sound that have a frequency of 19 kilohertz and a wavelength of 0.080 meters, how much time will it take for the sound to travel from one whale to another whale? The first thing we want to do is draw a diagram of what's going on. So we have 2 whales at 1500 kilometers apart, so 1500 kilometers apart. Now the other piece of information that we have is we have our frequency of the sound that's coming out as 19 kilohertz, and we're also given the wavelength, which is 0.080 meters. So the question asks us to find the time. How long will it take for the sound emitted by the first whale to reach to the other whale? So we have to try and work out the time. So it's a pretty tricky question because it's a little bit, it requires 2 steps. We have the frequency and the wavelength, which means we can actually work out the velocity pretty easily. So the velocity is actually equal to the frequency times the wavelength, which gives us 19. Now remember here, this is a kilohertz, so we're going to swap this kilo with a times 10 to the power of 3 hertz and multiply this with our wavelength. Now our wavelength is in meters already, so that's good. And it'll give us our answer in the standard form, which is 1529.5 meters per second. So now we have a velocity, 1529.5 meters per second. We have a distance, it needs to travel 1500 kilometers, and we need to work out a time. So hopefully you guys can figure out that this is a simple application of the speed equals distance over time formula, which means the time taken is going to be the distance divided by the speed. So the distance is 1500 kilometers. Now be careful, again, kilometers is not meters, so we're actually going to put a times 10 to the 3 to represent the kilometers to put this into meters, and we're going to divide this by the speed, meters per second, and this will give us the answer of 980.71 seconds. Because our distance is given to us in meters, our speed is given to us in meters per second, so the answer will be in seconds. Now we want to check if this answer makes sense. So our speed of the wave is around 1.5 kilometers every second. Now we have to travel 1500 kilometers. So yes, 980 seconds does make sense if that's how far it has to travel. So we accept this answer. A teacher attaches a slinky to the wall and begins introducing pulses with different amplitudes. Which of these 2 pulses, A or B below, will travel from the hand to the wall in the least amount of time? In other words, which one will hit the wall first? So let's draw this out. We have wave A and we have wave B. The only difference we have between wave A and wave B is the amplitude here. So which one do you think will hit the wall first? I'll give you guys a couple seconds to think about it. The answer is they actually hit the wall at the same time. So let's figure out why this works. What are the factors that affect how long it takes to get to the wall? It would be the speed. So the speed, if wave A was faster than wave B, then wave A will hit the wall first. But we know that our formula for the velocity is actually frequency times the wavelength. Now, they said the only difference between the 2 waves is the amplitude. Now, if we change the amplitude, which of these values is it going to affect? It's not actually going to affect any of them. The frequency is going to remain unchanged and the wavelength remains unchanged. You can have different amplitudes with the same frequency and the same wavelength. So that means the speed of wave A is going to equal to the speed of wave B, assuming that the frequency and wavelength are the same and the only difference is the amplitude, which means they will hit the wall at the same time. I hope you enjoyed that video. Remember to let me know if you have any questions so that I can answer them. And in our next video, we're going to be doing a very challenging wave problem. So stay tuned.